Hey guys, before we go into Spring Boot, let's touch base on Spring Framework. Okay, so we need to have some basic knowledge on Spring Framework before we go deeper into Spring Boot. Okay. So let's start with what exactly are the features of Spring Framework. I'll try to explain as much as I can in this video. Okay. The Spring Framework is an open source, lightweight, and comprehensive framework for building enterprise-grade Java applications. Okay, so before Spring, developers often struggled with complex XML configurations, heavyweight application servers, tight coupling between components, difficult unit testing, boilerplate code for resource management. So what Spring addressed was the challenges through principles, through Spring principles such as dependency injection, inversion of control, aspect-oriented programming, modular architecture, Gojo-based development. Today, Spring has evolved into a complex and complete ecosystem that powers a large percentage of enterprise Java applications worldwide. So, what problem did Spring resolve? So, consider a service that depends on a repository. Okay, so example, take a user service and it has an user repository for registering the user. So the repository saves the user. So in that class, we're going to instantiate the user repository, and through the register user method, we're going to save the user. So the instantiation of the user repository happens inside the class. The problems for this is it's a tight coupling, difficult to replace implementations. It's very hard to test. It violates dependency inversion principle. For example, testing requires real database access. So with Spring, what the problem that Spring resolves is, so the dependencies are provided externally by Spring. This concept is dependency injection. That means you have a variable inside the class called repository, and when the user service is instantiated, the repository is passed through the constructor. So this concept is called dependency injection. The core philosophy of Spring is built around several important principles. One is inversion of control. Okay, so the control of object creation moves from the application to the framework. Hence, the name is known as inversion of control. In traditional flow, user service creates a user repository. In Spring Flow, the container creates the user repository and it injects into the user service. Dependency injection. DI is the mechanism used to achieve inversion of control. Spring automatically injects required dependencies. Spring detects that user service requires user repository and it injects it automatically. What are the different types of dependency injection? We have constructor injection. This is a recommended approach. Through the constructor, you are injecting the repository here. The advantages are its immutable dependencies, easier testing, and recommended by Spring team. The second way of injection is setter injection, useful for optional dependencies. Third way is field injection. It's not recommended because it's difficult to test hidden dependencies and prevents immutability. The next concept of Spring is the Spring container. The Spring container is the heart of Spring framework. The responsibilities include creating objects, managing object lifecycle, injecting dependencies, managing configurations, and managing bean scopes. What are the different types of containers? We have Bean Factory. What is Bean Factory? It's a basic container implementation. It's rarely used directly, but it's lightweight and lazy initialization. Application context. It's an advanced container. The features are bean factory capabilities, event handling, internalization, AOP support, and automatic bean post processing. Most applications use application context. Next, we go to beans. What exactly are the beans in Spring? Beans is simply an object managed by the Spring container. Spring creates and manages this object. When it comes to life cycle of the beans, container starts. Whenever the container starts, the beans are instantiated. Next, the dependency injection. Using post contract, the bean will be ready and the application running. After the application completes, the pre-destroy annotation and the bean is destroyed. Next, we'll come to the bean scopes. What are the different scopes of bean? The default one is singleton, one instance per container. The next one is prototype. You have new instance for every request. The third one is request scope, one bean per HTTP request. Fourth one is session scope, one bean per HTTP session. Let's go to Spring modules next. Spring follows a modular architecture. Okay? So what this means is, we have core container, contains core, beans, context and expression language. Next is data access layer, it contains JDBC, ORM, transactions. It supports Hibernate, JP and MyBase. The next layer is web layer, it contains Spring MVC, REST support and WebSocket support. Next module is AOP module, provides cross-cutting concerns. Examples are logging, security, transaction management and auditing. Next module is testing module. It supports JUnit, Mockito and integration testing. Now let's cover the Spring configuration styles. What is the old style? It's XML configuration. Another way of configuring is using Java configuration, that is using annotations. The modern way is use the annotation configuration. What are the different types of annotations we have? Stereotype annotations. We call them as stereotype annotations or component, service, repository and controller. We use the REST controller annotation also for REST APIs. Next is component scanning. What is component scanning? Spring automatically scans packages using the annotation component scan. It finds, what does it find? It finds component, service, repository and controller. Let's go to the next topic, AOP, aspect-oriented programming. AOP handles cross-cutting concerns. Without AOP, let's take an example without AOP. You have method inside Java where you have to transfer the money, for example. So you have four methods: log, validate, execute, transfer and log. So all these are called sequentially. These methods are called sequentially inside the method transfer money. So with AOP, what you can do is log before and log after. Business code remains clean. You can use the annotation before, after and so on. The common AOP use cases are logging, security, transactions, monitoring, auditing and performance metrics. Let's go to the next topic, transaction management. Spring provides declarative transaction management. So what does this mean? So if an exception occurs, you go to roll back the transaction, otherwise you commit the transaction. So for this we have the annotation called transaction. Next is Spring expression language. Spring expression language allows dynamic expressions. Event handling. Spring supports event-driven programming. Example, in Java, if you say application event publisher, you want to publish an event, listening you can use the event listener. Whenever an event is published, you can listen to the event and process it. In Spring testing support, you have the annotation Spring Boot test. So let's take an example, user service test. This is a test I have written. Inside that, I am using the user service with auto-wide annotation and test. So Spring loads the application context automatically here. So why Spring became so popular? Let's understand. The features of Spring is IOC container. The benefit is loose coupling. Dependency injection. The benefit is easier testing. AOP. It's a cleaner code. Modular design. Use only what you need. In transaction management. It simplified database operations. Mojo program. No heavy inheritance. Integration support. Works with many technologies. Let's see what are the major differences between Spring Framework versus Spring Boot. Spring Framework is just a foundation framework. The core framework is the foundation. The Spring Boot is built on top of Spring. In Spring, you need to configure everything manually. It requires configuration. But in Spring Boot, everything is auto configuration. In Spring Framework, you need to set up everything manually. It's more setup, I would say. In Spring Boot, it is minimal setup. Spring Framework, it is suitable for fine-grained control. Okay. But Spring Boot advantage is it's suitable for rapid development. Can be used independently. Spring Framework can be used independently, but Spring Boot depends on Spring Framework. You can think of it like Spring Framework is engine and Spring Boot is car built using that engine. You want to understand the typical request flow in a Spring application. You can see whenever a client request is invoked, client sends the request. So who gets the request? How the request is processed is first it hits the dispatcher servlet. So dispatcher servlet sends that to controller. From the controller layer, we'll have the service. The service layer invokes the repository. Repository internally uses the database, the repository, and once again it comes back to the service, controller, and response. The real world example you want to imagine, just imagine a e-commerce application. You have the product controller which invokes service, and service invokes product repository, and repository invokes MySQL database or whichever database you configure. The Spring manages all these objects and binds them together automatically. So in short, I want to summarize, Spring is a lightweight modular framework that manages object creation, dependency injection, transaction management, and enterprise application infrastructure, so developers can focus on business logic. So what are the 4 pillars that every Spring developer must master? They are IOC, inversion of control, dependency injection, bean lifecycle and scopes, and aspect-oriented programming. Once these concepts become clear, understanding advanced topics such as Spring MVC, Spring Data JPA, Spring Security, and Spring Boot becomes significantly easier.